In this video, I want us to discuss this concept on the board, which is a continuation of the topic we treated last class. That is equilibrium of bodies in liquid. Last time we treated equilibrium of bodies equilibrium of bodies in solid, that is solid bodies. Now we want to continue with equilibrium of bodies in liquid. Now these are the concepts we are going to discuss under this subtopic as follows. We have Archimedes principle, the principle of floatation, upthrust, and density. Then relative density. Then we now take example. Now, what do we mean by Archimedes principle? Archimedes principle states that when a body is partially or fully immersed in a fluid, that is liquid or gas, it experiences an apparent loss of weight or an upthrust, which is equal to the weight of the liquid displaced. That is stated that when a body is partially or totally immersed in a fluid, that is liquid or gas, it experiences an upthrust, which is equal to the weight of the liquid displaced. That is the principle. Now, another one is what we call principle of flotation. Principle of flotation or law of flotation. Then principle of flotation states that when a body floats in a liquid, or a body floats in a liquid when the upthrust exerted on the body is equal to the weight of the body. That is, a body floats in a liquid when the upthrust exerted on the body by the liquid in which it floats is equal to the weight of the body. For that, in a simple statement, it means that a floating object that is displaces its own weight of the liquid in which it floats. A floating object displaces its own weight of the liquid in which it floats. That is the principle of what? Flotation. In other language, for a body to float in a liquid, the weight of the body must be equal to the what? To the upthrust exerted on the body by the fluid. That is the condition for flotation. Then, let's continue. Then what do we mean by upthrust? By upthrust, we mean, like I said when I was explaining Archimedes principle, upthrust means the apparent loss in weight of a body in a liquid. That is, upthrust is the apparent loss of a weight of a body in a liquid. It simply means the force being exerted on a body that is immersed in a fluid, that is liquid or gas. That force being exerted on such body, which is an upward force, is known as what? Upthrust. For instance, if you have something like a football, that is a pumped football, and you get water in a basin or water in any container, and you are trying to push that football down inside the water, you will experience that a bounce up. So as you are trying to press it down, or something like tire, as you are trying to press it down, it will be bouncing up. That force bouncing up is the upthrust being exerted on that body by the fluid, as well the liquid, for instance. So that is upthrust. Okay, then we have what we call density. But before I talk about density, let me explain what I mean by upthrust. For example, when you mass a body in a liquid, if the weight of the body in the liquid in air, the weight of body in air is equals to, let's give example, is equals to y, and the weight of the body in liquid, maybe in water, is equals to x, for example. So the upthrust of the body, the upthrust on the body when you're immersed in water, because the body will experience a loss of weight. What we're trying to say that when you measure an object in air and measure it, weigh it, take the weight of the object when immersed in a liquid, the weight in air will always be greater than the weight of the object in liquid because of the density of the liquid is greater than the density of air. That are making the body to experience an apparent loss of weight in the liquid. So the upthrust here now will be the upthrust. The upthrust of this body will be equals to the weight of the object in air minus the weight of the object in water. So this will give the upthrust on the body. The upthrust here will be the weight of the body in air minus the weight of the body in water gives you the upthrust. That is it. And this upthrust is also equal to the volume of the object, a mass, times the density of the liquid times acceleration due to gravity, because it is weight. So this one can also give the upthrust of the body. The volume of the what? Object, a mass in the liquid, times the density, this real means density of the what? The liquid, times acceleration due to gravity, can also give you the what? The upthrust on the body being exerted by the what? Liquid, fluid, or gas. Okay, now let's look at another concept here. Another concept here is density. So density, because I have mentioned density here, density is simply defined as the mass of a body per unit volume. That the ratio of mass of a body to its volume. That density is the mass of a body per unit volume, and the unit of density is kilogram per meter cube. That is density, kilogram per meter cube. Density, this symbol means density. So density, in other words, we say that density of a body is equals to mass of the body over volume. That is density. In other words, rho equals to m over v. This is density of your body. So you can see that density of a body is inverse proportional to its volume when the mass is constant, which means the higher the volume of a body, the lesser the density of the body, and inverse. So when you compress a body, the more you compress a body, the lower the volume of the body, the greater the what? The density, that's how heavy it will be. For instance, if you get a loaf of bread and you now compress it, when you compress it, the mass remains constant. You have not done any change in the mass. When you compress maybe a loaf of bread, when you compress it, you observe that it will become a bit heavier, like stone, than when it is not compressed. So when you compress it, you have shrunk it, and by so doing, you have reduced the volume and increased the density. But when it is not compressed, the volume is big, but the density is less. It appears lighter when it is not compressed. I mean, like a loaf of bread. That will give you an idea of what you mean by density and how it relates to volume of an object. So that is it. Then the unit of density is kilogram per meter cube, because mass is in kilogram and volume is meter cube, and this is ratio over, that's density. Of course, upthrust, the unit of upthrust is Newton, because it is a weight. It is Newton, it's a weight. Of course, unit of weight is Newton. Now, relative density. When we talk about relative density, we mean the ratio of the mass or weight of a substance to the mass or weight of equal volume of water. Not just weight or volume of water. The ratio of mass or weight of a substance to the mass or weight of equal volume of water. That is what? The relative density. We use water as a standard measurement for relative density, because the density of water is measured to be a unit. I mean 1 gram per cm cube or 1,000 kilogram per meter cube. So it's a standard for measuring what? Relative density of objects. So we use it to compare relative density of objects. So in other words, we can say that the relative density, of object is equals to the mass or weight of the object over mass or weight of equal volume of water. That gives you relative density of what? A substance. And the unit of relative density, it has no unit, because they have the same quantity up and down, the same parameter quantities. So that relative density of a body. You can also determine relative density of a solid using upthrust. Yes, using upthrust. In that language, for example, this general formula for relative density. Then for something like relative density of solid, for solid, you can use upthrust. In that case, also you can get relative density as the density of a substance, that the ratio of density of a substance to what? To density of water. So it can also be, relative density can also be equals, or relative density equals density of, this is density of of a substance over density of water. This can also give relative density. Density of a substance over density of water can give relative density of what? An object. Then for solid specifically, in terms of Upthrust, relative density of solid is equivalent to, you have the weight of that object in air over Upthrust in water. See, so that is the relative density of a solid equals to the weight of the object in air over Upthrust in water. Then when you want to get the relative density of a liquid, for relative density of a liquid, then relative density of liquid, for a liquid, it can be obtained in terms of Upthrust as the Upthrust in that liquid, that is a liquid other than water. For example, kerosene, petrol, any liquid at all that is not water. So relative density of a given liquid, which is not water, equals to Upthrust in that liquid over Upthrust in water. So you see as a standard. So that is it. That's the apparent loss of weight in that liquid over apparent loss of weight in water. That relative density of what? A liquid in terms of Upthrust. But this is general formula for relative what? Density. Because this will give us clue when we want to solve this calculation on the board. So with this analysis or explanation, it is time now we apply it in simple question on the board here. Remember that the density is mass over volume, like I said before. So let's look at the example of the question here. So this we okay. Now let's solve this quickly. Now the question example here. The question says a body weighs 0.40 Newton in air, then 0.35 Newton in water, and 0.37 Newton when filled a mass in another liquid. We are asked to calculate I, its loss of weight in water, that is the Upthrust in water, I, its relative density. Then I, that's question C, relative density of the what? Liquid. Now, solution to this question. Then we are told that the body weighs. So weight of the body in air, weight in air is given as 0.40 Newton. Then we are also told that the weight of the body in water, we are given to 0.35 Newton. And we are told that the weight of the body in liquid and non-liquid is equals 0.37 Newton. Okay, now what do you observe here? You can see that in air the body weighs higher than the weight in water. So when the body was measured in water, the scale reading of the weight and the balance shows 0.35, which means there is a loss of weight in water than when the body was measured in air because of the Upthrust. Then when the body was measured in another liquid or non-liquid, for example kerosene or any other liquid, it was observed that the weight of the body is 0.37. You can see that water is denser than that liquid because the greater the density of a liquid, the more the Upthrust it will exert on a body being a mass in it. Thereby the body will lose more weight in such a liquid. That is why in water it is 0.35, but in another liquid 0.37. So water is denser than this by this comparison. But in air there was no much Upthrust. There was no loss of weight. The weight in air is the actual weight, but the weight in other distance there's Upthrust. Okay, then we are asked to calculate its loss of weight in water, which is Upthrust. Then question I, for loss of weight in water. Of course, that is Upthrust in water. That is Upthrust in water equals weight of the object in air minus weight of the object in water. And that will give you, without wasting time, that will give you the weight in air is 0.40 Newton minus weight in water 0.35 Newton, giving you 0.05 Newton. So that is the upthrust. Because if you carry one, put here 10 minus 5, half 5, 3 minus 3, 0.05 Newton. That is the upthrust exerted on the body by the water. Then the question says, so the body lost 0.05 of its weight when immersed in water. That is the upthrust. In line with the Archimedes principle we stated earlier, that when a body is immersed or submerged in a fluid, that's a liquid or gas, it experiences an apparent loss of weight or upthrust. That is it, which is exerted on it by that liquid and is equal to the weight displaced. Okay, then the second question says, find its relative density. Now, relative density of the solid, relative density of that solid is equals to the weight of the solid in air over upthrust in water. And that will give you the weight of the solid in air is 0.04. 0.04 over upthrust in water is 0.05, which is very simple. That the upthrust in water is the weight in air minus weight in water, which we have obtained. So this is very simple. It is like having so the weight in air is, the weight of the object in air is 0.4, sorry. So this is like having saying 0.4 times 100 over 0.05 times 100. I want to divide this without using calculator, and that will give us, this will become 40 over, when you do this and do this, and you do this and do this, for this and this, over what? 5. Invariably get 8. So this is how we treat cases like this without calculator. That is it. You give them the same multiple up and down. You see. So that is it. It gave me 8. 8 is the answer. Remember, it has no unit. Then for I, we are asked to find, the question says, find the relative density of the liquid. So relative density of the liquid, already here means relative density of liquid, of that liquid. We give, like I explained before, that will be the upthrust in the liquid, which is very simple. Weight in air minus weight in liquid all over weight in air minus weight in water. And that is very simple. That will give weight in air is 0.4 minus weight in liquid. The weight in the liquid is 0.37 all over, let me bring this thing forward here, so for the want of space. So that will give us, the weight in air is 0.4 minus weight in liquid, which is 0.35, that weight in liquid, all over weight in air 0.4 minus weight in the weight in liquid is 0.37. Then weight in air 0.4 minus weight in water 0.35, and that will give us 0.4 minus 0.37. This is like this 0.40. Then you have 10 minus 7, 3, then 0.03. That's the upthrust in the liquid over upthrust in water is, we have obtained it before, to be 0.05. And invariably, this will give you 3 over 5. And 3 over 5 is 0.6. Remember, it has no unit. So the relative density of the solid itself, that is mass in the liquid, is 8. While the relative density of the liquid itself is 0.6. So this is how to tackle this. What are the practical applications of this? You can see that this is why you see ship carrying big loads and is still selling on the high sea without sinking. You can see some people using canoe to load items and still pedal it on the river without what sinking. You can see some swimmers using a life jacket and swim. That's why we use life jacket when swimming, to avoid what, being drowned in the water. Because when you wear the life jacket or use something like blown tire, that is a pumped tire for swimming, that for safety, it will make the person to have what, less what, density, so there will be upthrust on the water, so the person can float on the surface of water. These are the practical applications. For the ship, it is designed with buoyancy so that there's a large volume under it. That large volume, as you are loading good, it is displacing water until the displace equal to the volume. It will balance and be sailing. Though it has every ship has an amount of load. When it exceeds that load, it will sink. But when you now load within the range of that volume, the vacuum, then it will balance on the sea and will be floating without sinking. So these are the science behind those things, because of the principle of what? Archimedes principle, and what? The principle of flotation. So for a body to float, the weight of the body will be equal to the upthrust for the body to float. Otherwise, the body will sink when the weight is greater than the upthrust. And also, you can also design bodies to float based on the shape of the body, like we explained in terms of canoe design, ship design, and other things. And why we use life jacket, so that we have less understanding, so that the upthrust can be exerted on the body when swimming. So these are the sciences behind it. So with this, I believe you have understood the concept and principle of this and its practical application, as well as how to use it to how to tackle calculations involving upthrust and relative density. Thank you so much. I remain your friend and tutor here, Joe Newton. For more of these solutions or calculations problems in physics and mathematics, you can reach out to me through my contact line here for online classes through Zoom or Skype or Telegram as you are preparing for exams.